the modulus of complex number, so we've got a complex number z equals I plus y. Again, x and y have to be real. So the modulus is written like this, and it's simply equal to x squared plus y squared. So by Pythagoras, it's basically the length of the vector. We think of a complex number as a vector, it's the length of that vector. Sorry, forgot the square root. So, for example, the modulus of 3 plus 4i is the square root of 3 squared plus 4 squared, which I've chosen to be a nice number, 5. The complex conjugate of a complex number, if I stick with my complex number x plus iy, is simply x minus iy. Complex conjugate I'll write with a star. Sometimes people write z bar instead of z star. I prefer z star because bar is often used for other things like averages and so on. So in this example, the complex conjugate of 3 plus 4i is simply 3 minus 4i. So we can combine these results. If we multiply this by this, what happens? We get z times z star is x plus iy times x minus iy. Now, using the a squared minus a plus b times a minus b formula, we know this is equal to a squared minus b squared, but b squared in this case is iy squared, which is minus y squared. So basically in the end we end up with x squared plus y squared, which we observe is just the modulus of z squared. So a convenient way often to find the modulus of a complex number, or the modulus squared, is simply to multiply that complex number by its complex conjugate. Another thing to say about complex conjugate is that for any expression, if you've got some complex number w, which you write as p plus iq, for example, and p and q could be complex numbers as well, then the complex conjugate, is simply, you just change everything which is I into a minus I. And any complex number, you just take the conjugate. So this is going to be equal to p star minus I q star. So you conjugate everything. You see an I, you change it to a minus I.